Hi, in this video we're going to talk again about the 5-number summary and box plots, but in this specific video I really just want to talk about the 5-number summary. And follow-up videos we will construct box plots by hand and in Minitab, but right now I just want to talk about where these 5 values come from and what they represent in the data set. And specifically, here are the 5 values that make up the 5-number summary. The minimum and the maximum are quite easy to find. So you have a data set, and then if you ordered it from smallest to largest, our smallest is definitely our minimum, and the largest is the maximum. So if you had this as, on a quiz, you'd be like, yay, I have the minimum, I have the maximum. A little bit tougher, though, are the quartiles. And tough in the sense that just understanding the definition, where they come from. So here's the definition of quartiles. The first quartile we refer to as Q1. Now I should mention, now that we're into these definitions, we're finding values in an ordered data set. So if you just had a data set that wasn't ordered from minimum to maximum, it would be hard just to look at it and say, hey, that's Q1, it's separating, 25% below it, 75% above it. So you really want to order your data before you go about trying to find the first quartile. So what the first quartile is, it's the data value Q1 such that 25% of the data values are less than or equal to it, and 75% are greater than or equal to it. The second quartile, Q2, which most people have heard of or have heard it called median instead of Q2. It's that middle ordered data value such that 50% of the data value is less than or equal to it and 50% greater than or equal to it. And then along the same lines, we have the third quartile, Q3, and you can probably guess what I'm going to say. Once the data is ordered, Q3 is that value such that 75% of the values in the data set are less than or equal to it, and 25% are greater than or equal to it. So there's the quartiles. They're points that are splitting the data set into quarters. Once we have Q3 and Q1, a nice measure of spread is called the interquartile range, and it's just Q3 minus Q1, often referred to as the IQR. And this at least tells us, the middle 50% of the data, we have an idea of the length of that spread of the middle 50%. So again, it's kind of a good indicator. You have outliers or skew. What that middle 50% of data, what is the length of that? Let me see. I've added an example here just so I could show you where Q1, Q2, Q3 are in the data set. I'm not talking in this video how to compute them. I just want you to realize what these values mean with respect to being ordered in this data set. So here's the data set. I'm getting a little bit older and a lot of my really good friends are retiring. So I took a sample of my friends who are retirees, and I asked them, at what age did you retire? So here are the 11 data values that I obtained. I've already ordered them for you from smallest to largest. So usually you don't get a data set in this order, but I did this specifically to help us with this example. So easily we can pick off the minimum 59 and the maximum 73, and yay, those were nice. And now these quartiles. So I'm not saying how to compute it, but I'm telling you 64 is the first quartile. It's the value such that 25% of the data is less than or equal to 64, and 75% of the data is greater than or equal to 64. So you can kind of see this is the value that's cutting off the first quarter of the data. So we might as well go ahead to Q3. Here's Q3 at 72, and it's doing the same kind of thing. 25% of the data values are greater than or equal to 72, and the other 75% are less than or equal to 72. And median, being true to its name, like middle, it is the ordered middle data value. So we have 11 data values. So if we count in 5 from each edge, we're going to reach the middle. Here's 1, 2, 3, 4, 5, right? We've cut off that side, 1, 2, 3, 4, 5, and our middle is 68. So 68 would be our median. And you can see here, right, it's cutting half of the data values less than or equal to, half of it greater than or equal to. Since we have these numbers, we might as well take the opportunity to compute the IQR. So Q3 minus Q1 is 8. And the range is the maximum of the data set minus the minimum. So this is the entire spread of the data is 14. A couple of important notes. Quartiles, they don't necessarily have to be an observation in the data set. So sometimes when we compute the position of a quartile, it might lie in between two data values. So it's not the case that every data value turns out to be a quartile. We can have some values that are in between them. And quartiles, like the median, is not affected by outliers. So this is a really nice property of the median and why sometimes people use the median instead of the mean. So let's say, for example, I'd like to put a huge number here, but also want to be believable. Let's say someone, they love teaching. I know people that love it. I love it, but there are other people too. Let's say they don't retire until 110 years old. They've had a great career. This number is quite large, so if we were to compute the mean of this data set, that 110 would pull the mean toward the right. But when we're calculating the median, we're still just counting data values. In this case, actually, it'd be between these two data values. Actually, that's not quite true, right? It would be between, let me see, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yeah, I am right. It would be between these two data values at 69. What's the point? The point is the median is less affected by large values. So I was going to do, for an example, like if the upper order data value was 1,000, it would really have an effect on the mean. Or let's say down here I put, a 0 or a 1. They're going to have a big effect on when you calculate an average. But when you look at the median, you're just counting. So they have little effect. As they do on some other statistical values that we compute. Let's keep going here. Yeah, I thought I should mention Quartile calculations. Surprisingly, not every textbook or statistical software program or statistician computes the quartiles or where they're located in the same way. I'm still a little bit surprised about that, but there's different definitions for how to get that position, and we're going to talk about the one that Minitab uses, and Minitab's really is the most popular way to compute these, at least from textbooks that I've read and statisticians that I'm friends with. So anyway, calculating the position of Q1. So first, we need to know what this n is. I'm afraid maybe I don't have it written here, but n is the sample size of your data set. So let's just write that here so we don't forget that. So for the example that we just had, n was 11. So to find the position of the first quartile, we're going to take the sample size n, add 1 to it, divide by 4, and that will be the position of where Q1 is. So for an example, I just said, suppose you had a data set with 30 elements in it. 30 plus 1 is 31 divided by 4, 7.75. So we're going to look for the first quartile between the 7th and 8th order data value. And since we have 7.75, obviously when we interpolate, we're going to be a little bit closer to the 8th order data point than the 7th. The second quartile is the middle order data point. In the last example, n was equal to 11, and we just counted to the middle value. If it so happens that n is a even number, we're going to have to average the two middle numbers. The third quartile, we compute and we're just going to put a 3 in front of that n plus 1 over 4, and this is going to tell us the position of where that third quartile is. So again, I use the example if n is equal to 30, I put 30 in here for sample size. When you do the computation here, we get 23.25, so the third quartile is going to be between the 23rd and 24th ordered data value, and because we only have 0.25, it's going to be closer to the 23rd than the 24th. So I just thought I would point out in this example the positions of the quartiles. So we had n equals 11 data values, and 11 plus 1 is going to be 12 over 4 is 3. So I count in 3, 1, 2, 3, and 64 is Q1, and that's what we had on the other page. If we put 11 into this formula, we get 9 for the position of Q3. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Here is Q3. And since our data set is odd, the median is going to be right in the middle. So again, 1, 2, 3, 4, 5, 5 that way, 1, 2, 3, 4, 5, 5 that way, and 68 is our median. So in another video, I'll do an actual example, and we'll go through all this again. But I hope this makes sense. These measures are not too tough to find. I think though people aren't as used to finding quartiles as they are, let's say, a mean or a median. So I think it was worth the explanation. And if I had to just say one last thing, which I will, it's so important to order your data set first. If your data set is not ordered from minimum to maximum, it would be really tough to just visually say, hey, I think this number's my, first quartile. I'm not doing example 2 in this video, but I mean, look at this data set here. Could you visibly just say, here's my data set. Oh, it looks like Q1 is, 2.5 or something. You can't do that. So you need to order your data first and then do those computations of the quartiles. So I'll be talking, I'll be doing example 2 in another video, and then we'll start, constructing our box plots. So until the next video, I'll see you, and we'll be talking again soon.